Hi everyone. Once again, I've got out the Sharp QT12 Boombox and I've decided I am going to try and put this inside it. And this is a little Bluetooth module. I'm going to go through the process and my thinking around how I'm going to install this. Then we're going to install this in this radio. That should give it Bluetooth and give it a sort of new lease on life as a useful device, because the reality is I'm not going to listen to cassettes very often. So I'm going to put the radio away. We'll talk about how I'm going to install these, and then I'm going to install them. I should say I'm not using my microphone on this project because I want to be moving around a lot, and I'll be turning the camera on and off quite a bit. So apologies if the sound is not so good. So here are the parts we'll be using. This is a double throw, triple pole switch. So we'll switch, open this up. We'll switch right and left between, on one side we'll put the radio, on the other side we'll put the Bluetooth module. And on the bottom, we'll switch the positive power rail. So this solves a lot of problems. You could use a single pole double throw switch and switch the power, but then you'd need to implement transistor switching of some sort. I guess you could use relays if you didn't care about the power use, but you'd need to implement transistor switching of some sort to handle the audio. So this is the most straightforward thing. I ordered this one from AliExpress. We have our Bluetooth module, also from AliExpress. These are a dime a dozen. Well, okay, about $1 a piece. This takes 5 volts in. You can use a micro USB, and it gives you stereo out. It's got the Bluetooth chip, the clock, and the little antenna, and you can also put battery in. So this takes 5 volts in. And that represents a problem because the radio has unregulated 9 volts, which means that's going to peak up to about 12 volts. So we need to implement some sort of power. Now you could buy a 5 volt board with a buck converter on it, but my experience is those are pretty noisy and interfere with the radio, and well, I don't have one. Well, I mean, I do have boards, but I don't have one that I'm not using for something else. So what we could do is use a linear regulator. Here's one here. Sorry, it's not focusing. That's an LM3171, I think. Let me just hold it up here. Yeah. And so this can be set for different voltages by setting the resistors on it. Now, if you were building a power supply with this, you would use a filter cap on it to smooth the power supply. But I'm going to be really lazy and not bother because I see filter caps here of various sorts, and I'm going to count on the filtering built into this to be adequate to filter this power supply. If it's not, we'll put filter caps on it. And usually we put a reservoir cap and then a ceramic, right? Would be your usual approach to putting filter caps on that. So what I need to do is I need to calculate my resistor values to generate 5 volts. This I think will take anything from 3.5 volts through 5 volts. We'll go for 5 volts. And I don't see a power regulator on it at all. There might be some regulation in the chip, who knows, but that's what it claims on the seat. And obviously if you plug in USB, you're giving it 5 volts. So we know that works. Let's set it for 5 volts. So I'll get out the notebook, see if I can find a past circuit I used with one of these regulators and see if I wrote down the equation for calculating the voltage. And once I figure out what the what value I need for my resistors, then we'll figure out how the circuit is going to fit into the case. So this is goes back to December 18th, but this is the circuit that I designed to generate a 9 volt power supply for the battery chargers for some little Motorola GSM radios that I was playing with. That's in a previous video of mine. If you search for Motorola, that would probably find it for you. So this is what the base circuit for the LM317 is. So you've got 3 pins. You've got in with positive in. You have output, and you would put some filtering on that, and you would put some filtering on that. You have the adjust pin, and then you have your resistor divider between those. And by picking R1 and R2, you can set the voltage. And I set R1 at 240 ohms and R2 at 1500 ohms here to generate 9 volts for this circuit. So what I need to do is I need to calculate what those resistor values will be. Okay, so if you look at the scribble over on this side, I solved the equation, and that would set R1 at 330 ohms. And that would go, if you run through the math here, that gives, I don't know if that's going to show in there, that gives an output voltage of about 5 volts. So that's what we're going to do. R1 is going to be 330 ohms, and R2 is going to be 1K ohms. And that's it. That's our circuit. Okay, so we've got the 2 resistors in place, and now I've just got to figure out how it's going to go. So this is the adjust pin on the left, so that's going to go on there. That doesn't need anything else. This one is going to need to have this output wire connected to it, as well as go on here. And then this pin here is the power in, and we're just going to put red wire on that. That can be sleeved easily enough. This one, the problem is exactly how to get the heat shrink in there is really what the main issue is. So I'm going to do the heat shrink in a couple of segments here. One, smallest one that I can get on here, there we go, for the first bit, and then I'll slide some over that once that's cooled down and put that over as much of the pin as we can get to. We'll do this fairly short. All right, so that's soldered on there. We'll put the heat shrink over there, and that whole thing is nicely protected. So I'm not going to bother to heat shrink the power outside. We'll make sure that the 2 ends are, sorry, as I'm reaching for the iron, are properly protected. And I'll just get this one on here, like so. So just to show you why it doesn't really matter if you heat shrink this, that's because on these, the output is connected to the heat sink. So if you want to heat sink this onto something that's connected to ground, you have to have an insulator between it. So this, okay, that's not great looking soldering, but it also means it is kind of hard to solder, although I have a big tip on the iron, so it's not a problem. But this is really kind of messy. We'll clean that up in a bit, but so there's, there's not much point in worrying about heat shrink around that, but we do need to protect the outside pins. So there we go. We have the power supply connected. This goes to ground. That goes into our adjust pin here, like that. We have our 2 resistors, one now covered with heat shrink there, the other one that you can just make out. That would be R1 and R2. Here's our output, and here's our positive in. So what I'll do is I will get a 9-volt power supply. Let's see what we get out of this. So we've got, you can see I put a little bit more heat shrink tubing around the whole thing. We've got our power supply, it's at 3.6 volts. Turn the voltmeter on. set that for DC. Let's crank this power supply up to 9 volts. I've got no shorts, are they? It should go, yeah, I'll crank it up a bit more. Doesn't really matter. This will only go up to about that because it's connected to a 12 volt power supply, but there's a drop. Okay, so what we want to do is we want to check between, and my reads are all over the place here. So we want to check between our output here and ground, and we should see 2.5 volts. Let's make sure. Yeah. I have miscalculated something. Let me double check. In which case we will have to redo this whole thing. Okay, I'm able to measure this resistor in circuit, and it's 1K and has the appropriate. However, this one I can't see, and running the math, my guess is that I put a 1K resistor in there instead of a 330, and I see my 330 or a 330 sitting right here. So I think that's what happened. So I will have to get this off somehow, and then we'll solder in a 1K resistor, a 330 the way it's supposed to be, and then that will solve the problem. And we'll try again. I think I've got it all fixed. Let's pull this back in. We've got the power supply on here, 10.8 volts going in. And off camera, I am not doing a very good job. If you see, that says 5.08 volts, which is exactly what was predicted by the math. So what this shows is that the math will be correct, even if the execution is sloppy. It also goes to show that it's important, especially for things like this, which could fry other components, to check the voltages your thing is generating. So what we're going to do with this is put a little bit of heat shrink around here, like so, and then put some heat shrink over the whole thing. And I won't bother doing that on camera. Well, that took longer than it needed, but we now have our little 5 volt power supply package together. Well, it's just a 5 volt regulator. It isn't a power supply because it doesn't have any smoothing capacitors on it. Now, it would be straightforward to stuff a smoothing capacitor in there if you wanted to, right? You could just, if you didn't need a big one, you could just heat shrink it in there, or you could just put it across the power input on here, assuming your wires weren't too long, which is probably how I would do it. So we've got this, which we can tuck pretty well anywhere, keeping in mind that this is going to have 5 volts on it. All right, let's talk about where we're going to position this stuff. My original intention had been to run the switch over here because we already have the power and the headphone jack coming out, and there's room on here to drill it, and you wouldn't be drilling the red plastic, and that would have been my preference. But the cable I want to intercept is coming out of the radio, which is behind this speaker. And if you run the cables back and forth, we're going to have more issues with interference and have to concern ourselves with all of that. There is a cable that runs everything we need from the amplifier board, which is behind here, to the radio here, and we could just pull that out, run it to the switch, and drill the switch in right there. So this would just pop out right there. And I think that's what I want to do. I think that's the easiest way of doing it. So the question is, I think the thing to do would be to mount the switch first, and then I think these boards can just be mounted on the bottom of the cabinet. This one might be to get the antenna into a better position, you might be able to mount it right here on the back, just taped on, and this little regulator can just be taped on down here wherever it's convenient. That doesn't really matter. So here we are with the switch, and I've determined with the multimeter it works like I understand. So we're going to use this top row for plus, and we'll use the center goes, it says to the amp, but that's going to be power in on this side, for amp side, I guess we could say. Sorry, that's very hard to see. Amp side, this is radio side, and this is Bluetooth side. And then we're going to switch right and left, and I've labeled both sides so that I remember what I'm doing, because that appears to be an issue. We'll do power first and make sure that makes sense before trying to hook up anything else, to avoid putting 9 volts anywhere it shouldn't be. So I've got the cover off, and what I'm concerned with is whether there's enough clearance here. If I was to mount it there, and the clearance would be right there. There's a nice hole for running the wires through. And if I was to screw this all the way in, even not quite, it appears that there's more than enough clearance to get it in. So the question is, could we get it by these wires here? We'll probably figure that out. So yes, I think we'll be all right with putting the switch in there. So this is the wiring harness we're interested in here. As we have the wiring harness that goes from the amplifier board here to this, which is the tuner board. But we've got some complication here. This is the tone control. Okay, that appears this to be a separate that looks like this just goes to the tone control. So what have we got here? We've got, it's labeled over here in the bottom. It says mono stereo switch, right, left, plus battery, ground, and mute. So maybe we'll just try intercepting that there and see what happens as our first attempt at this. So I'm gonna go through the wire colors and figure out what's what, and then figure out a plan of attack. I think this one up here just has to go, it says to main power board, and it says tone, and I think this just puts the tone control in the circuit. Maybe. Or maybe this comes from the board to the tone control and then it comes back. But that wouldn't make any sense, and there need to be switching. Anyway, I don't entirely understand that. Let's ignore that. Let's operate with this. This here, that's the band switch. And this wire here is just for the microphone on this side. So anyway, let's try it. What do we got to lose, right? Okay, I think I figured out what everything is. We have the colors here, and we've got red, right, left, battery plus, which is, that's supposed to say switch. So that'll go to the switch here. And then we've got ground, which I'll tie into that ground, but we'll see if that works. If not, I might need to tie into a ground across the board. And we've got mute, which is brown. We don't need to do anything with that. So there's a stereo, there's a stereo indicator, that's a stereo indicator lamp, which is over here. And that's it. So what I'll do is I'm gonna wire this up and then see if it works, I guess. Seems to be the easiest thing to do. yeah, that's what I'm gonna do. Okay, I have now wired in the switch. It's wired in for the radio. I've got the grounds connected. I'm going to run the ground for the power supply. I'm going to run it all the way across, and I'll probably just hook onto the battery negative. My guess is that's not being switched when the usually it's the positive that they switch for the on the battery circuit. So that's easy to get to because it's right here. So what I'm going to do now, the radio should be working if I plug in the speakers. So what I'm going to do is I'm going to put power on it, and I'm going to try the radio. If the radio works, then yay, we haven't broken anything. And so then the second part is going to be to get this board in. I'm going to mount it right under here, and I'm going to mount my power board right there. Right there, doesn't matter, just tucked underneath, sort of around the battery, on the edge of the battery compartment here. So let me do that. This has been a bit fiddly, but I think it's all right. Okay, I plugged in the power. We have the radio, we have the stereo light. Stereo mono switch works. Power switch works. And we can go to AM. So the radio is working. When you take no load off of the front of this, it buzzes. We'll see if that's a problem when we put this board in. I'm hoping not. But of course we'll see how it goes. So next step is going to be to wire in the power to this board and then wire it into the other side of the switch here. All right, I've got it hooked up, and as you can see, it's working. There are a couple of things going on with it. You can hear a little bit of noise in the background maybe. But it's got a couple of issues. One is there's noise from Bluetooth when it's not active. It seems to go away when it's active, but that's hard to tell because it's way too loud for this. So it's driving it, or maybe it's driving it full 3 volts, but this is not designed to drive at a full 3 volts inside. So the solution is, of course, to turn down the Bluetooth volume, but the noise level is still high. Okay, so let me show you where I am. The two left and right channels are hooked up differently at the moment, and my problem is that I've got noise on them. So I tried a couple of things to try to figure out what was going on. I tried putting more capacitance on the power side. I don't think the problem is the power side unless the power is acting like an antenna and getting into the radio. But you'll see, here, let me turn to the other channel. It's a little louder. You can see, moving this around doesn't affect anything. So I don't think that's the issue. So there are 2 problems. One is it's playing much too loud. And I mean, you can put resistors in, but that's not actually doing it properly, and since it seems to be, it's voltage operated, not current operated, resistors don't do very much. I might try salvaging these, look to be stereo pots that came out of, and we'll see if those might work, in which case we could set them up properly and try putting a trimmer on it. The other question I had was one of, it was one of, well, would isolating it work? Now, we're not really isolating it because I don't think that the audio ground is isolated much at all from the from the power ground. I mean, I have run over here and not used it. I have played with that. It's better to run a separate ground, but still, we're just dependent on whatever capacitors in here providing filtering. So that's the second question. And so I thought, oh, well, let's put an isolation transformer on it. Not having one and certainly not having a stereo pair, I just used this 12 volt mains transformer, and I put it on the right channel. And let me turn it on and I'll show you what that does. Okay. So that's the left channel. That's going directly in. Now if we turn over to the right channel, it's helping a lot, but as far as I can tell, it's mainly just not operating. It's not the isolation that's helping. It's just that it's effectively a 10 times attenuation. So I'm going to have a look at, so I think that the fact that it's a transformer isn't helpful, but the fact that it's acting as an attenuator is helpful. So I think I'm going to see if I can get one of these off of this board. These are going to be a bear to desolder, but we'll figure it out. And yeah, this is an old DigiDesign interface. It won't run on any current Mac, but you know, we're gonna steal parts out of it, right? Nice quality. Well, I'm hoping these are like 10K pots. That would be perfect, I think. And then we can, you know, put the ground on the bottom, and put the signal on the bottom, put the ground on the top, and put the, you know, put our output on the wiper, and like you do with a normal volume pot. And if these are stereo, considering they've got 6 pins, suggest they are, that would be perfect. So I'm going to try that and see if that solves my problem. Then I can use this. This could either come through the side and we can use it as a Bluetooth volume, or it can just hang around in here set at some setting. And we'll see. At least I've got knobs for these, which are, you know, a bit 90s, but look all right. Anyway, more playing going on. You may or may not be able to see this. Let's slide it over a bit. So I have put this pot on. Oh, it's coming off. Well, that doesn't really matter. I did figure out how they work. They look to be 10K pots, and it's a stereo trimmer, I think. Anyway, I had it wired up, I think, correctly, and it helped a bit, but it still wasn't enough attenuation, I don't think. So I'm going to go see what I have in my collection of trimmer pots. I don't have stereo ones above this, so we'll see what I've got and see if I've got something that I can put on. If I figure out more or less a working combination, I can do it with resistors, right? It doesn't need to be a pot. We can have a whole mess of resistors in here doing the same job. But I do think that once you trim it down, the noise from this starts to be below noticeable, at least through something like this. So I think that's the way to do it. Yeah, I'm amazed I didn't cook this trying to heat the pins, but it's fine. So I'm gonna go see what I've got. Maybe try, well, we'll see. And I'll let you know once I've got it figured out. Okay, I have found a trimmer pot. It says 104, I think, on it. So I'll just double check that that's what it is. And we'll see if that will give us what we want. Yeah, so 104 should be 100K, and we should be able to see the wiper position if I can manage not to short out these leads. And the wiper's all the way down to one side. So I will replace this with this and then see if I can make that do what I want and come back. All right, well, I was able to adjust this trimmer, I mean, to get it more or less working. What that means is I've been able to match the volume reasonably closely to that of the radio. It's a little louder, but it probably should be. But you'll notice there's still noise in that. So the noise is getting into the amplifier. It's not coming into this. So what I'm going to do, just as a way of testing this out, is I'm going to take this power supply out and I'm going to use the USB power supply here and see if the problem is coming in through my power supply getting into the amplifier, or if the problem is related to just this causing the normal, it almost sounds like cell phone noise on older radios and things like that. I'm thinking it's not the power supply. If it is the power supply, then we'll put, or I'll put some filtering on the other side of this power supply and see if it does anything. If it's not, then what I'm going to have to consider is if it's possible to isolate this, expose the antenna, but maybe attach it here and put some metal foil of some sort between it and the rest. It could be mounted here, for example, although I'd have to extend the wires, but I could be mounted there or somewhere, and I could put some metal foil tape on the back and see if that helps. So there are a variety of things that we could try. The thing is, this antenna has to face the outside world. It doesn't have to have anything to do with this. So let's see. We'll try the external power supply first, and then we'll take it from there. All right, we're using an external power supply to drive the little board, and well, it's not perfectly quiet. The problem's mostly solved. So in other words, these wires running under here are transferring noise from this board into the amplifier section here. Now, so it's not these little wires that are the problem, it's these long ones. So what I'm going to do is I'm going to shorten this. I've now confirmed that these grounds are the same, so you don't in fact need this ground at all to make this board function. When I pulled the grounds off, it functioned just fine. So we'll tie this ground to here, which is tied to that one, and see how that works. Okay, so let me explain what I've done at this point. It's working. There are a few things that aren't working well. There's still noise getting into it. It sounds like noise from the Bluetooth section. It actually sounds a lot like GSM interference. As I showed before, if I use an external power supply, the noise goes away. So I think what's happening is noise is getting in through the ground plane, essentially, on this thing, which is absolutely not separated from the audio ground, unlike the Sanyo, which at least appears to have a separate audio and power ground, I guess you'd call it that. So there are a couple of things I could do about that. I don't think I can solve the problem by changing the power supply here for the same kind of power supply, because it's still going to share a ground with the with this. I could try putting a capacitor across the ground, I guess, or something like that. But I've tried a few things and that didn't seem to make any difference. I'll just show you how it is working. Oops. Let me turn the sound on. Well, you can hear some of the interference when there's no signal. If I turn on a signal, my resistors are working fine. The resistors, you see these little three-way things, those are set up to match more or less the settings that this trimmer was at before. So the trimmer settings were 96K and 7.2 for 103. Obviously these aren't standard resistor values, so I used 100K and 7.5K resistors. So that's what I used, and that's what's in there. Later on I found that I had some 50K stereo volume control knobs, so those would probably have worked perfectly, or one of those would have worked perfectly, but I didn't find it in my pile of stuff until after, so this is what we've got, and that's fine. So what I'm going to do is I'm going to try to get everything buttoned up. I'm not going to attach anything inside. I've put heat shrink tubing around this whole thing so we don't have something that's live at 5 volts getting in contact with anything else. It shouldn't have tucked down here. But I'm just going to put things in place and drill my hole in this. What I'm thinking of doing is actually replacing this with what I was trying to avoid, which is a buck converter of some sort, because the buck converter may have an isolated ground. I do actually have one right here. This one gives you, I mean, this is total overkill, right? But this gives you a control of a maximum current and maximum voltage. I have no idea what the current's set to. 1 amp usually is what I keep it set to, and the voltage here. This is essentially the same power supply as, let's see, as this one, right? Same chip. This just has a voltage display, and this doesn't have current limiting, so this is actually more useful. These are a bit overkill. You can find 5 and 3 volt low amperage buck converters all over, you know, eBay, AliExpress, and all that, and even Amazon. So I'll probably order, you know, some of those and see if that works better. This whole thing obviously is an exercise in patience and in trying things out to see what works in terms of converting these radios into having a Bluetooth device. It would be nice if the output was isolated from the input here, but it's not, and that's what's causing the problem, I believe. So this antenna is getting picked up by the ground, which is right here, right, and getting spread to the audio circuits. So, as I said, what I'm going to try to do is just tuck this back in place, understanding that it is, you know, at best acceptable at the moment. I do think this resistor divider system, which works just like a volume pot, is a pretty good solution for matching the output volumes. Obviously, I could have just put 2 trimmers on and called it a day and just set them by ear or with a scope, right? It would have been straightforward enough, but, you know, resistors are cheap. Okay, so I'm going to try to put this thing back together. I will bring you back when I drill my hole and try to mount this, and hopefully all this mess of wires will fit. But, you know, for the moment it's just going to get shoved in here in this side below the radio. The radio still functions perfectly, so we haven't destroyed any functionality of the radio in this process, which is kind of my key to me in trying to do this sort of stuff. Don't make it worse than it is at what it does, and try to make it do something new. So we'll see how this goes, and I will bring you back. I put the board in place. It's just sitting here pushed up by the mess of wires. I think that'll be fine for the moment. Here's the switch, here's the drill, and what we're going to do is I think I'm going to drill a 1/4 inch hole right here, which should let me get this through, and then we'll take it from there. I've tried putting some foil tape behind. I insulated it first. I tried putting some foil tape behind here, and that makes no difference. So the issue isn't this signal getting into the board here, it's that it makes its way into the ground plane and from there into the rest of it. So we need power supply isolation for this, and I'm going to try replacing my little linear power supply, well, it's not, with a buck converter and see if that solves the problem. That may introduce other problems. In general, my problem with buck converters is that they interfere with the radio functions of these sorts of older hi-fi systems. I don't think that's likely to be an issue here because I've got it set so the power is off to the buck converter, so should be okay. So what I'll do is I'll order a 5-volt buck converter or something, and we'll see how that goes. So I'm going to drill my hole, plug everything back in, and hopefully then we'll have this working after a fashion, and then there'll be a part, we got part 4 for this radio, there'll be a part 4 where I replace this power supply with something that will hopefully work a little better, and then we'll consider mounting it, although honestly it's pretty solid there with just sitting on the wires. Unfortunately, I only really have solid core wire in multiple colors at the moment, so that's what I've used. It's a real pain for something like this, but and not the best choice, but that's what I got, so it's what I used. One interesting thing about having it set up the way it is that this side of the radio is untouched. I have nothing here at all, and yeah, so everything is really sort of located over here, which is nice. Okay, so let's drill a hole, put it back together, see what it looks like. In terms of physical approach, there's some different choices we can make about how this is held in place. And then I'll put it back together, order a new power supply module, and see if that helps. Okay, I'm going to wrap this project up for today. I've got everything back together. I've got the wires trimmed. The switch works. Looks actually pretty decent over here. We have Bluetooth, but it sucks because there's so much interference. So the issue is going to be one of figuring out an alternate solution to that problem. And I'm just going to have to try another power supply and see if that works. This works quite well, and I'm quite happy with that as a way of switching between the two of them. If this fails as an alternative, I will put everything back together and I will put in a stereo jack with a switching stereo jack, which will allow you to put it in radio, plug in your stereo, which would then disconnect the radio and allow you to use an external source. That was, of course, one of my earlier approaches for this sort of thing, but, you know, it's nice if it's all inside. I am quite happy with this. I think this is, as I said, most of these projects are a learning thing for me. I was right, it does clear, although I did have to use every fraction of an inch of space I had available to me. And there are quite a few things I would have done differently about this. Most importantly, use more flexible wire in the future, which would have made things much easier and would have led to fewer broken connections as things were. For that I was futzing around with things trying to get them working. The radio is as functional as it was before. It just has a not entirely working Bluetooth option at the moment. And we'll continue to think about how that might be expanded in the future. Well, I hope you've enjoyed this part 3, part 4, I'm not even sure, of my working on this Sharp QT12 cassette radio. There will be another part when I figure out the power supply and or decide to just go for a jack over here instead. Hope this has been interesting. Thank you for watching.